Hi everyone, and welcome to Lecture 12 of Logic and Critical Thinking, where we'll discuss other fallacies. In other words, basically every type of mistake we can make that we haven't already talked about in the previous two lectures, where we went through relevance fallacies, that was Lecture 10, and then also induction fallacies, that was Lecture 11. So again, in this lecture, our final lecture of the course, we will discuss all the remaining types of fallacies that didn't really fit in well with those first two lectures. Although some of them, as I would argue or I'll mention, I think you might have thrown in into those previous lectures. For example, when we talk about inconsistency, you might have thrown that in lecture 10. But regardless, the idea is we'll wrap up or conclude the course in the final section of the course in our discussion of fallacies by discussing all the other ways we as critical thinkers can make mistakes, or hopefully, more ideally, right, we as critical thinkers will recognize others making mistakes. So that's the agenda here. As I typically do, I'll start off by just establishing in a little bit more detail what it is we're doing in the lecture, and then, as has been sort of the standard for these last few lectures in this final section of the course, what we'll ultimately end up doing is just going through kind of a catalog, if you will, of various ways you can make mistakes. I've tried to kind of label them in helpful ways. I always think it's kind of useful, at least, to categorize things and break things down and find common themes, at least insofar as they exist. And so I try to do that here. Now, the authors labeled, so this correlates to or corresponds to Chapter 8 of the textbook, which they titled Formal Fallacies and Fallacies of Language. But there's a lot more going on here. We're going to talk about fallacies that don't necessarily relate to the form of the argument or language issues. We're going to talk about some of those as well. So hence my reasoning then for labeling this entire lecture other fallacies, because we're dealing with more or less a hodgepodge of what's left. Okay, and so we'll start with what I've referred to as formal fallacies. We'll talk a little bit about language fallacies. There are certainly language fallacies that they discussed in the text. For lack of a better label, we'll talk in the middle about what I've referenced as other fallacies. Just they're not formal fallacies. They're not necessarily language fallacies, although they're kind of closely related, and they're not really anything to do with miscalculating probabilities. So I just called it other fallacies. And then finally, we'll discuss fallacies related to, in general, miscalculating probabilities, which a lot of what's going on here, I would argue, you could have thrown in with the induction fallacies lecture, the previous lecture. But be that as it may, they included this stuff in, again, Chapter 8, so we'll discuss it here in Lecture 12. So that's the game plan. Let's go ahead and begin here then. So we'll turn to slide 2 of the lecture, where we'll, again, flesh out in a little bit more detail, what's going on here, why are we here, what are we doing in this final lecture of the course. Well, again, we're going to discuss sort of the fallacies that were left over, the ones we haven't yet covered in the previous two lectures on fallacies, the previous two lectures in this final section, the fourth section of the course. Again, lecture 10 on relevance fallacies, and lecture 11 on induction fallacies. All right, everything that's left over in terms of ways we can screw up in the reasoning process, the idea is we're going to talk about those here. All right. So general heading, other kinds of fallacies that weren't covered previously. As they suggest on page 249 of our text, we will take a look at, quote, fallacies and mistakes in reasoning that generally are based on a faulty argument structure, or a careless use of language, which in particular here. So again, I would say, yeah, we do that, right? But that's only some of what we're going to do. A lot of what we're doing doesn't deal with the formal or language fallacies, although we are going to be discussing those as well. All right, so they point out a lot of what we're going to be doing, again, deals with the form or structure of arguments and what can be problematic about those, and then also issues related to the language that's being used. Right? So as I mentioned in the bottom of slide 2, we'll go ahead and begin by a discussion of, probably a brief discussion, because we really already discussed these in previous lectures, way back in section 2, actually. But we'll begin with a discussion of these formal fallacies, issues with respect to the structure of the argument itself. In other words, it doesn't matter what we throw in. The content of the argument doesn't really matter because it's the form itself is problematic. The structure itself of the argument is problematic. And so again, therefore, no matter what it is you throw in there in terms of its contents, okay, the argument's always going to be invalid. That's what we mean by formal fallacy. So let's go ahead then and turn to slide 3. Actually, so as I mentioned at the bottom, I briefly alluded to this a moment ago. Again, a lot of this we discussed in the previous section, section 2, specifically then lecture 5, which corresponded to chapter 10 of the text. Right? We discussed, again, when we were discussing the valid forms of these, valid forms of deductive arguments, we also, so common valid forms of deductive arguments, we also discussed at that time these then common fallacious or invalid forms of deductive arguments. And that's what we're going to revisit then here. Okay, so turning to slide 3 then, we'll discuss the first one, which, as I mentioned, right, so when we discussed these the first time, right, back in that prior lecture, we went through both the valid forms and then I contrasted those with the invalid forms. And now we're going to focus on these invalid forms. So like the first one, affirming the consequent, which we detail on slide 3, that's very closely related to the valid form of modus ponens. Okay, so by the way, I left some room up here for us. We have fewer items in our catalog this time around, so I was afforded a little bit more space. I could get them all up there and then also have some space here. So, right, the general idea is, premise 1 is if P then Q. Right. Premise 2, now the valid form, modus ponens, would just be P, right, and then the conclusion would be Q. This is a valid form or structure for deductive argument. No matter what you put in terms of its contents, this will always be valid, right? Provided these premises are true, this conclusion will have to be true. Again, that's what we mean by the idea that the argument is valid. If you need a refresher on that, again, go back to lecture 5. Right, so this is the valid form, right, known as modus ponens. What we're going to focus in on right here, though, on slide 3 is, again, affirming the consequent, which looks very similar but entails an important difference. And it's known as affirming the consequent because that's what premise 2 is doing. Right? It's affirming, so we're told if P then Q, and then we're told, hey, look, that consequent is true. So we're affirming the consequent. And remember, in a conditional, what follows the arrow is the consequent, and what precedes the arrow is the antecedent. Okay? Just some jargon there that you'll want to be familiar with. And so the person that's offering, not us as critical thinkers, we would never do this, right? But the person that's guilty of affirming the consequent, the form of the argument is this. Okay, it's very similar. You can see why, and especially given a little bit more complicated arguments, when the verbiage isn't, there's a lot going on, it can be tricky distinguishing the difference here. And that's hence a reason why this fallacy is so common, and because it is very similar to this valid form. Okay, but again, the idea is no matter what it is we plug in terms of the contents here, no matter what it is we put in here, the argument will always be invalid. It's a mistake. Whoever's concluding this based on these premises or reasons, right, that's a mistake. You shouldn't buy this conclusion based on these premises. Okay? So that's basically what I say throughout slide 3 there. I give you an example on the bottom, right? That's just one thing we could plug in there. If it's cool, then it has something to do with me. Okay? And then we're told it has something to do with me. And then they want us to conclude that it's cool, but hey, that doesn't necessarily follow. All right, so I want to give you another example too. Imagine I'm holding this up, right, and behind this, you don't know what it is, right? This is an intuitive example, I feel like, of affirming the consequent. It helps us sort of sense why this is a problem. Right? It's a very obvious example, I think, of a mistake. It's a mistake. So imagine I have something behind here, right? And let's start off with the valid form, modus ponens. And I say, look, if what's behind here is a cat, then it's an animal, okay? And then I say, it's also a cat, okay? And you have to assume, right, when we're assessing these arguments, that those are true statements, okay? If it's a cat, then it's an animal, and it's a cat. Can you conclude from those that it's an animal? Yes, right? Assuming that what I told you was correct, and we know, this is why I'm offering this example, we know that if it is a cat, then it is an animal. Right? Those match up with reality, if you will. Okay? So not only do we have to assume them, they're actually true. Not only do we have to assume they're true for the sake of assessing the validity of the argument, we already know that they are true, right? So if it's a cat, then it's an animal. Hey, look, it's a cat. We can conclude that it's an animal. But the mistaken form, right, this affirming the consequent, I'll start off with the same premise, right? If it's a cat, then it's an animal. But then we're told it's an animal. Can you conclude then that it's a cat? No. We were just told, hey, if it's a cat, then you know it's an animal. And then we were told it's an animal. We can't conclude then, as the person who's offering this sort of form, right, of the argument wants us to, we can't conclude that it's a cat just knowing that it was an animal. So, again, hopefully that makes some sense there. To me, that cat animal conditional always kind of helps figure out what's going on here. But again, that's the valid form. This is the invalid form. No matter what it is we plug in there, whether it's the example I offer at the bottom of slide 3, or it's the one about cats and animals, okay, no matter what it is we plug in here, it's going to be invalid. It's going to be a mistake, okay, to conclude this from these premises. So in that last example with the cats and animals, if it's a cat, then it's an animal. And then we're told it's an animal, we can't conclude from that it's a cat. Okay, these could both be true, and this can still be false. That's why it's invalid. That's why it's a mistake to conclude this. Okay, that was slide 3 then, affirming the consequent. We'll move on then to denying the antecedent, which is slide 4. So we'll leave most of this up here. And what we'll do, so denying the antecedent is very similar, as I mentioned at the top of slide 4, to the valid form of modus tollens. Okay? And so the mistaken, let's see. So this is the valid form, right, which is known as modus tollens. So let me give you, related to our previous example, if it's a cat, then it's an animal. Imagine I have this. You don't see what's behind the curtains, so to speak, but I tell you, right, if it's a cat, it's an animal, and then I say it's not an animal, then we know that it's not a cat because we were told, and we have to assume it's true, that if it's a cat, it's an animal, and then we're told it's not an animal. It can't be a cat then, right? That is a valid inference. So no matter, that was just one example of the contents we could put in or plug in. Again, no matter what the content is, if it matches this underlying form, it's going to be valid. Okay. Now, the one we're discussing here, related fallacy, very similar in structure, and that's why it tends to be somewhat common. But what ends up happening is we flip this around and we deny the antecedent instead of the consequent. And that's why the fallacy is known as denying the antecedent. The second premise, that's what it's doing. It's denying the antecedent, and then they want us to conclude erroneously that we can deny the consequent of the conditional in premise 1. Okay, so let's read this. Let's plug in an example. Let's stick with the cat example first. Okay, so again, we'll have the same first premise. Okay, imagine I have the curtains up here. You don't know what's behind the curtains, and I'm telling you, if it's a cat, it's an animal, and then I say it's not a cat. Okay, so you know whatever's behind the curtain. If it was a cat, it had to be an animal, and then you also know it's not a cat. Does that give you license to infer that it's not an animal? No. I mean, it could still be an animal. It might be a dog. Right? We were just told if it was a cat, it would be an animal, and then we're told it's not a cat. It could still be an animal. Okay? We don't know definitively that, and then whatever's behind that curtain is not an animal. And to conclude this would be a mistake. I'll give you another example at the bottom of slide 4. If it's cool, then it has something to do with me. Okay? And then we're told it's not cool. So then we're told it has nothing to do with me. Hey, well, maybe not cool stuff also has something to do with you, right? So that would be another example of some other kind of content that we could plug in to that basic form, right? And it has that same fallacious underlying structure, so it's going to be invalid. So those were both examples of denying the antecedent then. So that concludes our discussion of denying the antecedent. We'll conclude our discussion of formal fallacies by revisiting and for this one we'll have to change up the premises, revisiting the error or mistake known as the undistributed middle. So let's erase this. And it's related. I mean, this one's not as similar as I think the other two were to the valid forms that we discussed previously, but it's somewhat related to the valid form known as a chain argument. So like if P then Q, and then premise 2 would be if Q then R, and then the conclusion would be if P then R. Okay. That is valid no matter what it is you plug in terms of the contents of the argument and whatever it is. As long as these variables are consistent, what you're plugging in, that will always be a valid argument. So if it's a cat, then it's an animal. If it's an animal, it lives on Earth. We can conclude then that if it's a cat, it lives on Earth. Okay? If those premises are true, the conclusion has to be true. Now, the undistributed middle, as mentioned again on slide 5 here, the general form is listed there in the middle. And it's got a somewhat similar look in terms of its structure, but it's certainly different, and that's why then it's a mistake rather than being valid like the chain argument is. So again, this is the undistributed middle. Okay. We're told if P then, let's say R, and then we're told if Q then R, and then they want us to conclude if P then Q. Okay. So because both of these things are related to R in some way, they want us to sort of identify these two then. Well, that's a mistake. Okay. And real quick, again, this all revisits stuff we talked about in section 2. You know, why is it called the undistributed middle? Well, if you remember, the A, E, I, O standard form claims, right, our discussion of when categories have been distributed and when they're not. So this is the same as all P R R, right? Remember, in an A standard form A claim, the only term that's distributed is P. That's the only thing we know something about definitively about all members. Okay? So all of these are standard form A claims, and meaning the only thing that's going to be distributed in all of these is the first, right, the antecedent, the first term. And so the middle term, in other words, the term that doesn't appear in the conclusion but appears in both premises, R in this case, it's not distributed. It's never distributed, right? It's nowhere is it ever distributed. It's not underlined here, it's not underlined here, it's never distributed, and therefore, as we talked about back in that, that section, that would break one of the rules, and hence we would know right away that it's invalid. So it plays on that discussion of distribution, which we talked about again back in section 2. So I just wanted to talk briefly, in case you were wondering, why is it referred to as the undistributed middle? Why is it called that? Well, that's why. Okay, so some examples. The one I listed at the bottom, I like that one. To me, most of the time these are pretty obvious, as opposed to a lot of the times when you encounter a case of affirming the consequent or denying the antecedent, it might not be near as obvious, and you can fall victim to these a lot. I would argue a lot easier than is the case with this one. At least, again, that's my opinion or my experience. So, I'll give you some examples. One at the bottom there, that was taken verbatim from page 235 of the textbook. Premise 1: all card sharks are willing to lose money on a bet, or if they're a card shark, they're willing to lose money on a bet. Okay, these logically are the same, right? They're saying the same thing. So if you say if they're a card shark, they're willing to lose money on a bet, it's the same thing. The same thing as saying all people who are card sharks are people who are willing to lose money on a bet. Okay, so just FYI. So premise 1: all card sharks are willing to lose money on a bet. Premise 2: all gamblers are willing to lose money on a bet. So then they want us to conclude erroneously or fallaciously that all card sharks are gamblers. Okay? Well, no, just because they both have that feature or characteristic in common doesn't mean that they're identical. Okay? And to conclude that would be a mistake. Another example that I thought of, right? All men breathe oxygen is, again, very clearly a mistake, right? All men breathe oxygen. All women breathe oxygen. Or in other words, if it's a man, it breathes oxygen. If it's a woman, it breathes oxygen. Then they want us to conclude, therefore all men are women. Or if it's a man, it's a woman. No, that's a mistake, okay? Just because they both have something in common doesn't mean they're identical. So that was slide 5, and that will conclude then our discussion of the formal fallacies in this lecture, or this chapter. Again, this lecture 12 correlates or corresponds to chapter 8 of the textbook. So let's go ahead and move on then to discuss language fallacies, or at least the two that we'll mention here. We'll begin with equivocation. So this is slide 6 of the lecture notes. This is related, reflects back on, as mentioned, the second bullet point there on slide 6. Reflects semantic, well, actually both these, this and the next one, these language fallacies, they reflect our discussions of semantic and syntactic ambiguity back in lecture 7, and which corresponds to chapter 3 of the textbook. So if you need to, go ahead and revisit our discussion back again in lecture 7. So what is equivocation? So we're talking about this one first. Whoops. What is equivocation? As they define it, this is from page 238 of the text. Equivocation, quote, is related to semantic ambiguity and occurs when a sentence contains a word or phrase that is open to more than one interpretation. And that is always an issue. We want to be on guard when we discuss issues of clarity. We always want to avoid, right, issues with respect to ambiguity, not be susceptible to multiple interpretations, right? Not discuss things or offer our points in language that is open to more than one interpretation, or that is hence ambiguous. Okay. So they give a very obvious example of equivocation. This is from page 237. Quote, banks are on the sides of a river, and the place where I keep my money is a bank. Therefore, I keep my money on the sides of a river. Obviously conflating the two distinct definitions or connotations that we have that are associated with bank, right? And conflating them in a strange and clearly mistaken fashion. So hopefully that would be an example of a equivocation that we would easily detect. Okay? Here's another example that I came up with, and bear with me as I get it up here. Imagine a player, so imagine a football team, right? And one of the players says something like this. Okay? Coach says, we need to stop screwing up all the time and make sure we line up on the right. That's going to be the source of the equivocation here. Side. Okay. Hence, so then boneheaded player wants us to conclude, hence you idiots, says the idiot, you idiots need to stop calling plays to the left side. Okay. So in the first, right, the mistake turns on the conflation of two meanings or senses of the word right. Okay. Here, it was used as correct, right? We need to line up on the correct, or go in the correct direction, run the plays in the correct direction. Okay. And here it was used, right? We used the opposite of the different sense of right, namely right versus left. Okay, not correct versus incorrect, but right versus left. And so here he's using right in that other sense and saying we need to stop going, left and instead go right. But that's not the way he was using it here. Okay, so hopefully the teammates would immediately throw a flag on him and say, "Come on, right? we're better critical thinkers than that. You're guilty of equivocation. And that is then our discussion of equivocation. We'll move right along then to amphiboly. This is slide 7. Another language-related mistake that we can come across. I apologize for any glitch that might have happened there. My video stopped recording there. And so I'll just pick up again in our catalog here with our discussion of amphiboly. I've gone ahead and put up an example, which I'll get to here in a moment. But again, we're revisiting here with our discussion of these language fallacies. What we discussed back in, what lecture was that? Lecture 7, which again corresponds to chapter 3. So we discussed back then in lecture 7 issues with respect to when a concept or term is unclear, right, and open to more than one interpretation. That would be semantic ambiguity, and that was the issue with respect to equivocation. And then we also discussed when the structure of what's being said yields a lack of clarity, right? Because the structure is open to, given the structure of what's being said is open to more than one interpretation, and that is what we mean by syntactic ambiguity. And so here, our discussion of the amphiboly, the mistake of amphiboly, that reflects then an issue with respect to syntactic ambiguity, a lack of clarity arising from something to do with the structure of what's being said. Okay, so top of slide 7, as I mentioned there, citing page 238 of the text. Amphiboly in turn is related to syntactic ambiguity, which reflects a lack of clarity due to, quote, the structure of the sentence rather than a single word or phrase, end quote. So that's what distinguishes syntactic from ambiguity from semantic ambiguity. And both of these, there are issues with respect to ambiguity, or a lack of clarity, but there is that difference, right? It's semantic versus syntactic. So I love their example from 238. Thought this was a great example. Quote, if you want to take the motor out of the car, I'll sell it to you cheap. Well, the issue here is, what is it referring to, right? That could be referring to the car once the motor's taken out, right? Or is he suggesting that he or she is willing to sell the motor itself, right? What part of the structure of the sentence is the it referring to? We don't know. There's a lack of clarity there. Hence, it's open to two equally valid, if you will, interpretations or legitimate interpretations. Okay? We don't know what this person really means. They need to be clear. That hence the mistake. And then another example, which again we referenced and talked about back in chapter 3 in our discussion in lecture 7. A common one type of statement that I still come across, that you maybe have come across when you're filling out forms or preparing to do something usually bureaucratic related, right? Related to bureaucracy of some sort. Maybe you're leaving the country. Who knows what it is? But you come across statements like this, and this is definitely an issue. What exactly, if you were presented with this, what exactly are you going to come, with? Well, if you were me, you'd probably bring all 3 because you're not sure, right? But it's open to two equally legitimate, valid, however you want to put it, interpretations. Okay? On the one hand, we could read it as saying, look, you need a driver's license and, right, a photo ID or passport. Right? Option 1 here. So you better bring your driver's license and then either a photo ID or a passport. Either one of those would work. Okay? Or does it mean you need a driver's license and photo ID? You need to bring both of those, or you can bring a passport. Okay? Depending on which way you're interpreting the statement, okay, you just bring a passport, that may be sufficient. Or if the person or whatever entity is providing the statement, if this is the interpretation, that passport won't be sufficient. Okay? But really, the issue was on them, right? They were guilty of amphiboly here. There's an issue with respect to a lack of clarity, with regard to what they're saying, given the syntax or the structure of their statement. Okay? Really, the onus is on them to be clear in this case. Okay? But we might nevertheless, to avoid a lot of hassle and trouble and loss of time on our part, we might want to give them a call, or just, like I said, bring all 3 if you're not sure, right? Okay, so that wraps up our discussion of language fallacies, or at least Equivocation, and Amphiboly here. We'll turn to, for a lack of a better label, what I've referred to as other fallacies now. So we've wrapped up Amphiboly. And these are the ones, again, for lack of a better way of putting it, they just don't fit or mesh with the other major headings. So we'll discuss these. And then we'll move on to, so this is miscalculating probabilities. It actually corresponds then to these four down here, not these, just FYI. Hopefully that's clear. So we're turning to slide 8 here. And we'll discuss what's known as the fallacy of composition. Pretty straightforward. This is from page 77 of the 10th edition, quoting as the top bullet point on slide 8. The fallacy of composition occurs when someone, quote, reasons from the fact that each member of a group has a certain property to the conclusion that the group as a whole must have that property. Okay, so just because something's true of the individuals comprising a group, this illustration is probably not going to work. Just because something's true of the individuals comprising a group or a larger entity doesn't mean that whatever's true of those individuals is going to be true of the group or true of the whole. Right? So what's true of individual members comprising a group may or may not be true of the group as a whole. And as we'll see, it works the other way too. That's the fallacy of division, right? To infer that what's true of the individuals comprising a group is true of the group, or to infer that what's true of the group is true of the individuals comprising the group, those are both mistakes, and those are what we're turning to here. So really the only difference here is what direction, right, the mistake is. So in the first case, fallacy of composition, you're making the mistake, you're inferring, right, incorrectly that what's true of the individuals is true of the group as a whole. So great example that they've mentioned in every recent iteration of the textbook, and it's been the case for many, many years, at least if I recall correctly, and that's, the example of congressmen and women. Just because individual representatives in Congress have high popularity and high ratings doesn't mean that Congress as a whole has high popularity or high ratings. And it's often the case that individual representatives do have high popularity, high ratings, but then Congress as a whole is not so highly rated. For whatever reason, that oftentimes is the case. So again, in this instance then, it would be a mistake, right, to infer that just because, individual representatives of various states are very popular, that Congress as a whole is very popular, because that oftentimes isn't the case, right? Oftentimes, individual Congress, representatives really are popular, are highly rated, and nevertheless, Congress isn't very popular and is not highly rated. Okay. I like their second example, which I believe is new to this edition, from 239. Quote, this building is built from bricks, therefore it must be rectangular. So this person is inferring that just because each of the bricks comprising the building is rectangular in structure, that the building as a whole, right, must be rectangular. But that doesn't follow. You can still have a different shaped building using rectangular bricks. Right? So again, that was the fallacy of composition. And then turning to slide 9, then we'll discuss a very similar mistake, but again, working in the reverse direction. So fallacy of division, right, works in the reverse direction, where you infer that, again, just because something, or that because something is true of the whole or the group, that it's then true as well of the individuals comprising the group. But that doesn't follow. That's not always the case. So as I mentioned at the top of slide 9, the fallacy of division occurs when someone, quote, reasons from the fact that a claim about a group taken collectively is true to the conclusion that the same claim about members of the group taken individually is also true. Again, that is a mistake. Really like the example that they mention on page 240. They referenced, I think it was the 1970, I don't remember the exact year, 72 maybe, of the Miami Dolphins and their really good undefeated team. Where is it? Oh, they don't actually reference the season, I don't think. I think it was like the early 70s. But anyway, right, great team, greatest team of all time, you might argue. And so if someone were to infer from that, well, they at the very least were they the best team of that year, right? So if somebody were to infer from that then that they had the best quarterback that year, the best running back that year, the best wide receiver, et cetera, well, that would be a mistake. Okay, just because something is true of the whole, in this case, the team, the team as a whole was the best, right? Doesn't mean that the individuals comprising that whole, okay, the quarterback, the receiver, the running back, that's going to be true of them too, right? That they're going to be the best. Right? And I don't know enough about the Miami Dolphins that year to know whether or not that running back or the quarterback, Bob Greasy, whether or not he was in fact the best quarterback. Right? So, but to infer that again is a mistake. That's what we mean to indicate by this fallacy of division. Another example they provided on page 239, the mail carrier example. Quote, letter carriers in this town walk hundreds of miles each day. So they're saying something about what's true of the group. And then they immediately say, Cheryl, who delivers letters to my block and doesn't look very athletic, must be exhausted every day after walking that far. Well, just because, right, the first statement is and they mention how this is related to grouping ambiguity, right? That the first statement, right, is referencing letter carriers as a whole, and then their second statement, right, they're applying what's true with respect to letter carriers as a whole and applying it to a specific letter carrier, right? Well, again, just because it's true of the whole, all letter carriers, doesn't mean that it's going to be true of individual letter carriers. No, what we meant when we say letter carriers in this town walk hundreds of miles each day is the collective group, right? We don't mean that it's then also true of each individual. So that's fallacy of division. That wraps up slide 9 then. Move on then to slide 10 and we'll discuss, again, this is still other fallacies, so hence the arrow here. We're still under what I've headed other fallacies. So again, this is confusing explanations with excuses. I don't think anything is too terribly difficult or complex here. The idea is just when somebody is simply trying to explain something, if we make too much of that, right, and further they're trying to excuse something or justify something by simply trying to explain why something happened, that would be a mistake on our part. Okay, again, the idea is an explanation in and of itself isn't indicative of someone suggesting an excuse or trying to justify something, right? Someone can, without trying to justify or excuse something, simply try to explain why it happened, okay? And we have to remember that and not automatically get incensed maybe when someone tries to explain how the Nazis garnered power, okay? Not immediately presume when they offer this explanation that they're also they're with justifying or excusing what the Nazis did. And that was an example again that I think the authors mentioned in the text. As I mentioned at the top of slide 10, we have reiterated throughout the course the difference between arguments and explanations. Same sort of general idea here, right? It's one thing to explain something, it's another thing to excuse or justify something, and we have to keep that in mind. So quoting page 241, right below that, accordingly, a quote, speaker may simply be trying to explain why things happened as they did, which is not the same thing as excusing, never mind justifying those actions, end quote. And quote, it is one thing to explain why or how something may have happened, and it is another thing entirely to justify or excuse the event, end quote. Again, that's from page 241. So I think that's pretty straightforward. We just have to make sure we keep that clear in our minds at all times. Just because someone's offering an explanation of why, and oftentimes when this mistake happens, it's with respect to tragedies or bad stuff. Right? We have to remember that somebody can simply be offering an explanation for why that bad stuff happened and not be trying to excuse or justify it. So they mention, again, reiterating the same point from page 429 of the 10th edition, and should commit this fallacy, quote, if you assume without thinking about it that anyone who tries to explain the causes of bad behavior is trying to excuse it, end quote. So that is confusing explanations with excuses. Again, I apologize if there's any glitch there. Computer video stopped recording. I don't think the universe wants our course to come to an end, but this enabled me to go ahead and put up here. I'll pick up with confusing contraries with contradictories. And that allowed me, I guess, to go ahead and put up what we'll need here visually to discuss this mistake. So this is going to harken back to what we discussed in lecture 4, which corresponds to chapter 9, and our discussion of the square of opposition, or rectangle of opposition. And one thing I would say, so here we're again discussing confusing contraries with contradictories. Out of all these, this might be the most difficult one to sort of follow, and see why it's a mistake, but I think I really like their example, actually. I think it helps. It's very helpful to sort of illustrate how it's possible to make this sort of mistake. And it really rests what's going on here. Well, as the name suggests, we're confusing what's known as contraries with contradictories, right? So it's one thing. So this again goes back to all those things we talked about in lecture 4 or chapter 9. So standard form claims, I referenced a standard form A claim earlier. Okay, so I went ahead and put all those standard form claims up here, right? The square of opposition, right? And give you the basic forms, right? So a standard form A claim is all P or Q, and you can put whatever you want in for the variables, right? And that's a standard form A claim. So all cats are animals. A standard form E claim would be no P or Q, no cats or dogs. Standard form I claim would be some P or Q. And then a standard form O claim would be some P or not Q. So again, if you need a refresher, go back and check out lecture 4, reread chapter 9. That's where we went into detail with respect to this square or rectangle of opposition. So we're not going to delve too deep into that, just enough to kind of see what the mistake is here. Okay, so remember, we need to talk about these relationships here, the important ones here. Remember that the contraries, okay, A and E, so these are known as contrary, that these can both be false, right? But they can't both be true. Okay? So they can at times, they could have the same truth value, right? They can both be false, but they can't both be true. It is possible for them to both be false, though. Hence, there are times when both of these could have the same truth value. Okay? Well, when we say something's logically opposite, that can't happen. So what we mean to say, or what we ought to mean, right, when we say something is opposite from something else, is that, right, logically speaking, you can't ever have the same truth value. And that's not the case with respect to the contraries. Again, they can both be false. They just can't both be true. And the same thing the case with respect to the subcontraries. Okay? They can at times have the same truth value. Hence, they're not logically opposites. Okay? They can both be true. So some P or Q can be true, and some P or not Q can also be true. Okay? Of course, it depends on what we plug in, right? But it's possible for both of these, okay, to be true. They just can't both be false. Okay? And what's important here, with respect to the mistake, is to recognize they can, at times, have the same truth value. Well, that's not going to be the case when things are truly logically opposite. What it means to be logically opposite is you can't have the same truth value. Okay? That's only the case with respect to A and O claims and I and E claims. Okay? Those are the only logically opposite standard form claims, right? So those are the only relationships that are truly indicative of logical opposition, right? They will never have the same truth value. So if all P or Q is true, then this has to be false. That some P are not Q, that has to be false. It will never be true when this is true. Likewise, if this is true, no P or Q, then this has to be false. Some P or Q has to be false then. And it will never have the same truth value. Okay? And the mistake then is to misinterpret, right, these as being logically opposite. You can kind of see why, at first glance, well, these kind of seem like they're, contrasted. But the critical point to bear in mind is if they can have the same truth value, they're not logically opposites. Okay? If they can ever have the same truth value, then they're not logically opposites. And to speak of them as if they were then logically opposite, that would be a mistake. Okay? That would be confusing contraries with contradictories. Okay? And I love their example. So I think that's everything I wanted to say on slide 11. Talked about the relationships here, what it truly means to be logically opposite, and only the contradictories are actually logically opposites. That was the main point then on top of slide 12. So as I mentioned, this mistake then comes down to forgetting that, losing sight of that, and then talking about these as if they write A and E claims as if they're actually logically opposite. And so this quote's page 242, the second from the bottom quote here. Quote, two claims that cannot both be true but can both be false are not exact opposites. Okay. And quote, to treat contraries as if they were contradictories is fallacious reasoning, end quote. Again, that's from page 242. I really like their example. So again, this is the bottom quote. Imagine a visitor saying, quote, I understand that all the fish in this pond are carp. All the fish in this pond are fish that are carp, or however you want to put that, okay? As long as it's named form, okay? The curator says, no, quite the opposite, in fact. Okay, so they're saying, no, it's the opposite. Some. So in other words, what they're really saying, right, the curator, they're just saying, hey, some of the fish aren't carp. But what the person, right, the visitor erroneously infers, because they're conflating contraries with contradictories, they go over here, okay, and they jump to the conclusion. None of them are carp, just because the guy said it wasn't true, right? That all of them are carp. He infers, right? And the curator said, hey, it's the opposite. He infers, well, then none of them aren't. No, he's just saying, hey, look, some of them aren't carp. Not that all of them aren't carp, or sorry, that none of the fish in the pond are carp. Right? He's just saying that some of the fish in the pond are not carp. Okay. Yeah, I thought that was a good example. Just keep in mind, again, if they can ever have the same truth value, they can't be logically opposites. Okay, so that's confusing contraries with contradictories. We'll move on then to slide 13, where we'll discuss consistency and inconsistency. At least that's what they refer to this as. In previous editions, they actually refer to this as inconsistency ad hominem, which I like better as a label. And they used to lump it in with their discussion of all the other ad hominem fallacies that we discussed in lecture 10 when we talked about, again, all the other ad hominem fallacies, and that was lecture 10 on relevance fallacies. And the idea being, when it comes to these ad hominem fallacies, as you'll recall, the person's bringing up something about the person or the source that's offering the argument or the position, and so, by pointing out something about the person or the source, they're erroneously suggesting that they've undermined the person or the source's position or argument. Okay, no, you always have to, right? That's irrelevant. These other things are irrelevant. You always have to address, hence the idea that they're relevance fallacies. You always have to address the claim or the argument itself. Right? So we discussed that idea of these ad hominem fallacies. Well, something similar is going on here. So that's, again, I like what they used to call it, inconsistency ad hominem. I put that out. Was that the second thing from the top there? So I prefer that. We could have discussed this, again in what was that, lecture 10. If you would have called it this, regardless, they included it here, so we'll discuss it here. What's going on here? Well, the person guilty of the inconsistency ad hominem, they're pointing out that the source of the current position or argument, right? They formally held a position or argument or offered an argument that was at odds with the current one, right? It wasn't consistent. As if then that's reason to reject the current position or argument. Right? Well, no. We always have to analyze, assess, in this case, the current position or argument in and of itself for its own merits. Okay? After all, when we learn, don't we change our position? Okay? To suggest people always have to be consistent, right? That would be like suggesting that we never change our minds even when we learn we screwed up. Okay? No, just because somebody's position has changed over time doesn't mean that their current position is problematic or fallacious, right? And to suggest that, right, to suggest that that because they formally held a different position, that their current position is incorrect or illegitimate, that's a mistake. And that's what we're indicating here when we label that sort of thing inconsistency ad hominem. That's what we mean to indicate by that fallacy. So, top of slide 13, this comes from page 244. We must remember, quote, the knowing that a person has been inconsistent does not tell us a thing about his or her position, and specifically whether it's any good or not. Okay, we always have to analyze that position itself. So their example from page 211 of the 10th edition, going down a couple points there. Quote, Moore's claim is inconsistent with something else Moore has said or done. Therefore, his claim, belief, opinion, theory, proposal, etc., stands refuted, end quote. No, we always have to go in and analyze the claim, belief, opinion, theory, or proposal itself. And that's basically what I say there at the bottom of slide 13. Already mentioned that. Okay, so that is the inconsistency ad hominem. And that will wrap up our discussion of what I've labeled other fallacies. So now we'll turn to our final subcategory of other fallacies, the subcategory being miscalculating probabilities. So all four of these, final fallacies have to deal in one way or another with miscalculating probabilities. Okay? So returning to slide 14, and some of this I would argue, could have been, especially the last one here, arguably included in the last lecture, lecture 11, when we talked about induction fallacies. But regardless, right, they included it here in chapter 8, so we'll throw it in with lecture 12 here in our discussion of other fallacies. So the last four that we're mentioning here, again, they all are related in the sense that they have to deal with miscalculating probabilities in one way or another. Okay? And that's the top point of slide 14. And as I mentioned, that top point, we will start with then this mistake known as incorrectly combining the probability of independent events. And I'd almost say that should be probabilities, but regardless, it's just a grammatical thing, right? Incorrectly combining the probability of independent events. Okay, that's the issue here. So this is mistake 1 under miscalculating probabilities. So this is quoting page 245. It's kind of in the middle of slide 14, page 245 of the current text. The key to understanding this mistake is to keep in mind that, quote, one independent event cannot affect the outcome of another. Whether one happens does not change the probability of the other. When we gauge the probability of two independent events, both happening, we multiply their two individual probabilities. Okay? We have to remember that. And, a lot of people make this mistake, probably even myself sometimes, because this is kind of tricky math stuff that a lot of us just forget, very easily. But again, if we make the mistake, it is a mistake, right? So what kind of mistake are we talking about here? I really like their example. I think it's very helpful. So this comes from page 246. Quote, since there are 6 sides on a die, the chances of rolling a 1 are 1 in 6, or 16.7%. Therefore, the chances of rolling 2 of them in a row are 2 in 12. Okay? That's a mistake. The math just doesn't follow. They're incorrectly sort of combining the probability of independent events, right? And in those cases, we have to multiply, as they said earlier, right? So the idea is you roll a 6-sided die one time. The odds that it comes up 1 is 1 in 6. Right? And then we have a totally separate second roll. And the idea is, well, that also is 1 in 6, right? 1 out of 6 sides is a 1. And then they want to say, well, what are the odds? Right? The issue here is, well, what are the odds of us rolling a 1 in both events? And the mistake that's made is, well, they just add 1 and 1, we'll add that, we'll add these. Okay, well, it must be 2/12 or 1/6. No, right? Because that just reduces to the same fraction, right, or same probability. No, and it wouldn't matter. Another one of their examples, they added, like, I think the denominator, but not the top. Well, that's a mistake. Or maybe it was the other way. They added this, but, kept this the same. That's a mistake, right? None of those are correct, right? You would be, if you did any of that, screwed up math, right? You would be guilty of incorrectly combining the probability of independent events. Okay? The only correct way to figure out the probability of both these unique, distinct events happening being the case is to multiply, as they say. Okay? So multiply, so it would be actually, what are the chances of you rolling? So you could roll both 2 different dice at the same time. So what are the odds of you rolling snake eyes? It's not 2/12 or 1/12 or 2/6 or any of that. No, it's 1/36. It's actually far less likely than any of those other numbers or faulty solutions would have suggested, right? No, it's actually far less likely than those other, again, suggestions or solutions would have indicated. Okay, so you screw up and incorrectly sort of add these instead of multiplying the probabilities, then you're going to end up with incorrect math, which is a mistake, right? And mistaken reasoning. So again, that was incorrectly combining the probability of independent events. So that's 14. We'll move on to one of my favorite, because I think so many of us, even critical thinkers, we can be lulled into this. I think it's just so common. That's why it's one of my favorites. I don't know why that's the case. I guess I just like discussing it because I think, again, we all are kind of susceptible to it at times, right? We get into this fervor of thinking like that there's streakiness going on when there's not. So what do I mean here? So we're talking about gambler's fallacy. So turning to the quote, this is the middle of slide 15. It's quoting page 371 of the 9th edition. This is, quote, the idea that the probability of an event in a random sequence depends on preceding events in the series. So, what is it, craps? What is the one with the red and the black? I don't gamble much. You know, in the casino, let's say red is hit so many times, right, in a row. People around, right, are going to start thinking, oh, red's hot, as if the implication or suggestion being everybody should bet red as if it's more likely this next time, right, assuming red and black are equally likely here, right. The suggestion being, well, since red has hit, so to speak, the previous 5 times, let's say, well, it's especially likely then to keep being the case. Well, no, or it's more likely to keep being the case. No. The odds that it'll be red this next time are never any different. It's always, if it was equal to black, right, 50%. That never changes, no matter how many times. Even if it was 10 in a row, 100 in a row. Of course, it's extremely unlikely, but you could envision in that scenario how there would be more and more people falling victim, right? The more in a row, right, the red happens, the more people are going to think, oh my gosh, there's really something to this. Red is really hot. No. That's still a mistake, okay? And an event where the probability is 50%, that will always be the case, regardless of what preceded that event. It's a unique event in itself, and to treat that differently because of what transpired before, that's what we mean to indicate by the gambler's fallacy. It's called the gambler's fallacy because it's so common with gamblers, right? They think that they're super hot, right? They've had great luck the last week, so that's going to necessarily, right, mean that they're on fire, keep going, right? Or they're particularly susceptible to this kind of thinking, right? The example I give you at the bottom, that's kind of the same thing, right? So just because for quarter, right, heads and tails, 50% chance, right, when you flip a quarter that it's going to be heads, and it doesn't matter whether you flip heads 4 times in a row on that, or 2 times out of the 4. The probability on that 5th flip that it's going to be heads is 50%. Okay? And to lose sight of that, to think otherwise in any sense, right, because of what happened before, because of those previous flips, you'd be guilty of the gambler's fallacy. Okay? So that is the gambler's fallacy. One that, I'm glad they pointed this out. I don't think it's probably quite as common as the gambler's fallacy, but I do think it's one that, even critical thinkers, if they're not careful at times, can fall victim to, and that's overlooking prior probabilities. All things being equal, we have to not lose sight of the initial probability of something happening, right? And that's what this mistake reflects, right? Losing sight of the overall probability of something happening in the first place. Okay? So again, this is slide 16. The second point down, it's a quote from page 247. Quote, the prior probability of something is its probability of everything else being equal. And this fallacy, quote, occurs when someone fails to take underlying probabilities into account, end quote. So that's from page 247. I forgot what example they actually used. Oh yeah, they mentioned football versus hockey. And I have a similar example. So my example there on slide 16, let's go ahead and read it out here. Peter Parker was the male senior high school basketball player of the year in Texas last year, while Sammy Smith earned the same accolade in Montana. Clearly, they have the same odds of being the nation's #1 college recruit next year. So, look, it's obviously great to be the player of the senior high school player of the year, right, in any state. But it's especially great if you do it in Texas, given how much more populated Texas is versus, say, the average state, or especially Montana, which is on the extreme opposite end in terms of population, right? It's one of the least populated states in the country. So while, kudos to, who was it? Sammy Smith, it's still great to be the senior high school basketball player of the year in Montana. Right, it's saying a little more to be the senior high school basketball player of the year in Texas. Okay, And so if someone were to conclude, right, as I mentioned in the bottom bullet point, or sorry, at the bottom of the last statement and then the middle bullet point there. If they were to conclude, clearly they have the same odds of being the nation's #1 college recruit next year. That's not going to be the case. Okay? In fact, who was he? Peter Parker is going to have a much higher likelihood of being the #1 college recruit because he had to beat out many more competitors to earn his accolade in Texas than Sammy Smith did in Montana. Okay, so and to come to that conclusion, that would be a mistake, right? To assume they have the same odds of being the #1 college recruit. Right? In other words, to kind of be the #1, let's say, basketball player, deemed the #1 basketball player of the year in the entire country. Right? They don't have the same odds. You have better odds if you came out and won the player of the year in Texas than you would, all things being equal, if you won the player of the year from Montana. Okay? All other things being equal, I should say. Okay. So that was overlooking prior probabilities. We'll move on to our last one. Again, I think they could have just as easily put this one in our in chapter 7. We could have included it in our last lecture when we discussed induction fallacies, but regardless, here it is. As I had mentioned in at least one, if not both, the prior lectures on fallacies, the real key here, what we're really after, is to make sure we identify the mistake. How we want to label it, that's another issue, right? We just want to make sure that we identify that there is a mistake. Okay? Call it this, label it as a relevance fallacy or induction fallacy or other fallacy. That's kind of a side issue, right? It's not as important as recognizing that there is a mistake to begin with. Okay? So I'll reiterate that theme here as well. And so who cares which lecture it falls under? We want to make sure that we cover this, right, and realize that this is a mistake regardless. Okay, so again, what is the mistake? Faulty inductive conversion. So in general, as they point out, so this is the quote from page 247, towards the middle of slide 17. Quote, information about the percentage of A's that are B's does not in itself tell you anything about the percentage of B's that are A's. So kind of above that, as I mentioned, and it erroneously entails inferring that because whatever percentage of X's are Y's, that percentage then it holds true of Y's being X's. No. Okay. And to infer that would be what we mean by being guilty then of a faulty inductive conversion. So, they gave a lot of great examples. I think this is, when you see them, right, and hear them, a lot of times, not most of the time, I mean, sometimes they can be tricky and it's not necessarily straightforward that you're dealing with a mistake, right? But a lot of times it is obvious. So for example, there's from page 247. Quote, almost everyone who has Alzheimer's disease wants 8 carrots. Okay? Therefore, so let's say, right, 99% of people who have Alzheimer's disease, 8 carrots. Okay, so 99% of people who have Alzheimer's disease, 8 carrots. So that if somebody was guilty of a faulty inductive conversion in this case, then, and this is their example, what they're going to do then is infer that 99% of people who eat carrots are going to get Alzheimer's disease. Well, that's not necessarily true. Who have or will get Alzheimer's disease. Okay, that's not necessarily true. So I'll go back and finish the quote itself. So almost everyone who has Alzheimer's disease wants 8 carrots. Therefore, eating carrots makes it more likely that you will get Alzheimer's disease. However you want to put it, this is a different way of sort of couching the same kind of argument in slightly different language. Same sort of underlying mistake. Okay. Second example, this is mine. Most people, and this is the very bottom of slide 17, most people that stare at the sun for 57 minutes go blind. Okay. You shouldn't conclude from that. That's almost certainly true, that if you stare at the sun for 57 minutes, you're probably going to go blind. But don't conclude from that most people that are blind must have stared at the sun for 57 minutes. Okay. That's not going to be the case. They're probably blind from birth or from other sources rather than staring at the sun for exactly 57 minutes. Maybe they only stared at it for 55 minutes. All right, so another example of an illicit or faulty inductive conversion. Sometimes this is called illicit inductive conversion, by the way. Another example, they might have had one like this. I can't remember. Yeah, this is similar to, yeah, this is actually one of their examples. Most football players are men. So then if somebody wants to conclude from that, right, so American football, it's true, at least professionally. Let's say most professional football players are men. If that's true, right, we don't have any license to conclude from that most men are professional football players. Okay, just because it's true that most professional football players are men doesn't mean it's going to be true that most men are professional football players. And if you concluded that, right, you'd be guilty of a faulty inductive conversion. And that is slide 17. And that, my friends, wraps up our discussion not only of miscalculating probabilities, not only of our discussion of other fallacies, not only our discussion of section 4 of the course, but that wraps up the course in general. And I know it's going to be tough, hold back the tears, but I will offer, as I alluded to, I think at the beginning of this video, I will offer a conclusion of sorts, a conclusion video where I'll suggest ways you can continue to get your philosophical fix if you so desire. Kind of offer some reflections on the course and what I hope you kind of gain from it, and kind of wrap things up. So we'll provide one extra video at some point here, but that's it. That does conclude section 4, our discussion of fallacies, as well as the course in its entirety. So that is logic and critical thinking. I hope you enjoyed not only the lecture, not only the section, but the course as a whole. Again, please do join me for that conclusion video where I'll try to wrap everything up for us. But I'll leave you then with, again, lecture 12 corresponds to chapter 8 of the textbook, the 13th edition. So if you're taking the course, I'll leave you again with the homework. I did want to mention actually that I try to give you kind of an idea of our labels and how they match up with the homework in the back, because it's very similar to the previous 2 homework assignments where you read something and then or at least the bulk of your homework, right? You're exercise 8.4, you're reading a passage and then trying to identify which of the fallacies we talked about in this chapter or in this lecture best applies. And so they give you a list there. Pretty much all of the ones we've talked about are in there, except they don't include some of them, like this one is not given as an option, right? Confusing. So some of these aren't given options, but they pretty much list all of these individually, with a few exceptions. This one as well. So these 3 aren't listed as options at all, so they're not in 8.4. You don't even have to worry about them. But then conversely, right, H is listed as an option for miscalculating probabilities. And per their instructions, as I mentioned, per the author's suggestions in their notes on that page, I do want you to further distinguish. So if you identify one of these, hey, this is miscalculating probabilities, letter H, I want you to, as I mentioned on slide 18 and in the course schedule, I want you to further differentiate and indicate, which of these 4 in particular it is. So make sure you do that. I just wanted to note that. Okay. But again, that's it. Hopefully you enjoyed the lecture, the course in its entirety. And please do join me then for that final conclusion video. Thank you.